Chemistry helps us understand the world around us. From the food we eat to the air we breathe, chemistry is everywhere. It explains how substances interact and form new products. This makes it crucial for students, especially in the 10th grade. Learning chemistry provides insights into life processes and materials. It's not just about memorizing facts. Chemistry develops problem-solving skills. It teaches us to analyze information and draw conclusions. This skill is invaluable in everyday life. Understanding chemistry aids in making informed decisions. For Class 10 students, mastering chemistry is important. They learn foundational concepts for higher education. These include chemical reactions and equations. A strong grasp prepares students for advanced studies and careers. In conclusion, chemistry offers numerous benefits. It enhances our understanding of the natural world. As we delve into chemical reactions, we see how chemistry shapes our lives. Chemical reactions transform substances into new ones. They are at the heart of all chemical processes. Bonds between atoms break and form new ones, creating products. This involves energy changes, either absorbed or released. Think of it as a dance of atoms and molecules. Reactants rearrange to form new products. This leads to new substances. Reactions occur at different speeds, influenced by factors like temperature. They are seen in everyday life. Cooking food involves chemical reactions. Burning petrol in a car releases energy. Chemical reactions are crucial in natural and human-made processes. They are fundamental to chemistry and life. They explain how substances change and interact. Understanding them gives insights into the universe. Chemical equations are symbolic representations of chemical reactions. They provide a concise way to express the changes that occur during a reaction. In a chemical equation, the reactants are listed on the left, the products on the right, and an arrow separates them. This arrow indicates the direction of the reaction. Writing a chemical equation requires knowledge of chemical formulas. Each element is represented by its chemical symbol, and compounds are represented by combinations of these symbols. For example, the equation for the reaction between hydrogen and oxygen to form water is written as 2H2 plus O2 yields 2H2O. This shows that two molecules of hydrogen react with one molecule of oxygen to produce two molecules of water. Chemical equations also convey important information about the proportions of reactants and products. The coefficients in front of the chemical formulas indicate the relative amounts of each substance involved in the reaction. This is crucial for understanding the stoichiometry of the reaction, which refers to the quantitative relationships between the reactants and products. In conclusion, chemical equations are a powerful tool for chemists. They allow us to describe chemical reactions in a clear and organized manner. By mastering chemical equations, students can gain a deeper understanding of how substances interact and transform, which is essential for studying chemistry. Chemical reactions are all around us, and many of them are quite familiar. One common example is the reaction of baking soda with vinegar. When these substances are combined, they produce carbon dioxide gas, which is why the mixture bubbles and fizzes. This reaction is often used in science experiments to demonstrate chemical changes. Another everyday example is the rusting of iron. When iron is exposed to oxygen and moisture, it reacts to form iron oxide, commonly known as rust. This reaction is a slow process that occurs over time, leading to the degradation of metal objects. It illustrates the importance of chemical reactions in the natural world and their impact on human-made structures. Combustion is another type of chemical reaction that is widely observed. It occurs when a substance reacts with oxygen to produce heat and light. Burning wood in a fireplace or a candle flame are examples of combustion reactions. These reactions release energy, which is harnessed for various purposes, from heating homes to powering engines. In summary, chemical reactions are an integral part of our daily lives. They occur in cooking, cleaning, and even breathing. By understanding common chemical reactions, students can appreciate the role of chemistry in everyday activities and recognize the practical applications of their studies. Section 5. The Art of Balancing Chemical Equations. Balancing chemical equations is a fundamental skill in chemistry. It involves ensuring that the number of atoms of each element is the same on both sides of the equation. This is important because it reflects the law of conservation of mass, which states that matter cannot be created or destroyed in a chemical reaction. To balance a chemical equation, one must adjust the coefficients in front of the chemical formulas. This process requires practice and a systematic approach. Begin by identifying the elements present in the equation and count the number of atoms of each. Then, adjust the coefficients to ensure that the number of atoms of each element is equal on both sides. A common strategy for balancing equations is to start with the most complex molecule. Adjust its coefficient first, and then move on to the simpler substances. This helps in achieving a balanced equation more efficiently. Remember, only the coefficients can be changed, not the subscripts in the chemical formulas, as this would alter the identity of the substances involved. In conclusion, balancing chemical equations is an essential skill that helps students understand the quantitative aspects of chemical reactions. It reinforces the concept of conservation of mass and prepares students for more advanced topics in chemistry. Section 6. Synthesis reactions. Synthesis reactions are a type of chemical reaction where two or more simple substances combine to form a more complex product. These reactions are often characterized by their simplicity and are fundamental to the formation of new compounds. A classic example of a synthesis reaction is the formation of water from hydrogen and oxygen gases. In a synthesis reaction, the reactants are usually elements or simple compounds. During the reaction, these substances chemically bond to form a new compound. This process is often accompanied by the release or absorption of energy. The general form of a synthesis reaction can be represented as A plus B yields AB, where A and B are the reactants, and AB is the product. Synthesis reactions are important in both natural and industrial processes. For example, in nature, plants synthesize glucose through photosynthesis, using carbon dioxide and water in the presence of sunlight. In industry, the synthesis of ammonia from nitrogen and hydrogen is a crucial process for producing fertilizers. In summary, synthesis reactions are a fundamental type of chemical reaction. They demonstrate how simple substances can combine to create complex products, playing a vital role in both biological systems and industrial applications. Understanding synthesis reactions helps students grasp the basics of chemical bonding and compound formation. Section 7. Decomposition reactions. Decomposition reactions are the opposite of synthesis reactions. In these reactions, a single compound breaks down into two or more simpler substances. This process often requires an input of energy such as heat, light, or electricity to overcome the bonds holding the compound together. Decomposition reactions are essential for understanding how complex substances can be broken down into their components. A common example of a decomposition reaction is the breakdown of water into hydrogen and oxygen gases through electrolysis. When an electric current is passed through water, it decomposes into its constituent elements. This reaction is not only fundamental in chemistry but also has practical applications in producing hydrogen fuel. Another example of decomposition is the breakdown of calcium carbonate or limestone into calcium oxide and carbon dioxide when heated. This reaction is an important step in the production of cement. It demonstrates how decomposition reactions are utilized in industrial processes to obtain useful products from raw materials. In conclusion, decomposition reactions are a key type of chemical reaction that helps us understand the breakdown of compounds. They highlight the role of energy in chemical processes and are crucial for both scientific studies and practical applications. Mastering decomposition reactions enables students to appreciate the dynamic nature of chemical transformations. Section 8. Single and double displacement reactions. Single displacement reactions involve an element reacting with a compound, displacing another element. For example, zinc reacts with hydrochloric acid, forming zinc chloride and hydrogen gas. Double displacement reactions involve the exchange of ions between two compounds. This results in two new compounds like silver nitrate and sodium chloride forming silver chloride and sodium nitrate. These reactions are key to understanding chemical reactivity and are widely used in labs and industry. Section 9. The significance of mastering chemical reactions and equations. Understanding chemical reactions and equations is vital for students pursuing chemistry. These concepts form the foundation upon which more advanced topics are built. Mastery of chemical reactions and equations enables students to predict the outcomes of reactions, a skill that is essential in both academic and practical settings. Chemical reactions and equations also enhance problem-solving skills. They require students to think critically and apply their knowledge to balance equations and predict reaction products. This analytical thinking is not only valuable in chemistry but also in other fields of study and everyday decision-making. The ability to understand and manipulate chemical reactions has practical implications. It is crucial for the development of new materials, pharmaceuticals, and sustainable energy solutions. By mastering these concepts, students contribute to advancements in technology and the betterment of society. In conclusion, mastering chemical reactions and equations is a fundamental aspect of chemistry education. It equips students with essential skills and knowledge that are applicable in various scientific and technological fields. As students continue their studies, these foundational concepts will enable them to explore and innovate in the world of chemistry and beyond.